scientists turn carbon dioxide into ant venom biofuel. Scientists have created a device that turns carbon dioxide into formic acid, a venom produced naturally by ants that can be used as a biofuel. The prototype electrolyzer, which runs on renewable electricity, produced the purified liquid fuel at high concentrations, potentially paving the way for a new mechanism to produce energy and reduce greenhouse gas emissions at the same time. CO2 is a potent greenhouse gas and is one of the primary drivers of climate change. When emitted into the atmosphere, it stops heat from Earth escaping into space. Since the start of the Industrial Revolution, levels of atmospheric CO2 have tripled, a shift attributed to the burning of fossil fuels. While other greenhouse gases are more efficient at trapping heat, methane, for example, CO2 lingers in the atmosphere for far longer. Earlier this year, it was announced that atmospheric CO2 levels had increased to 411 parts per million, the highest monthly average ever recorded. Finding a way to take CO2 out of the atmosphere had been the focus of many scientists around the world, and numerous proposals for how to do this have been made. More recently, researchers have been finding ways to turn CO2 into something useful: fuel. Formic acid is a promising fuel carrier, but producing it at the required levels is costly and inefficient. Researchers led by Chuan Xia, from Rice University, Texas, have now developed a reactor that uses CO2 to produce this liquid fuel at concentrations that could become commercially useful. Formic acid is an energy carrier, Peiyuan Wang, who made the reactor, said in a statement. It's a fuel cell fuel that can generate electricity and emit carbon dioxide, which you can grab and recycle again. It's also fundamental in the chemical engineering industry as a feedstock for other chemicals, and a storage material for hydrogen that can hold nearly 1,000 times the energy of the same volume of hydrogen gas, which is difficult to compress. That's currently a big challenge for hydrogen fuel cell cars. In their study, published in Nature Energy, the researchers describe how they made the prototype electrolyzer and the performance achieved. For the reaction, the team created a catalyst that is more stable than others, so instead of producing it on small milligram or gram scales, it can be produced on kilogram scales. That will make our process easier to scale up for industry, Xia said. The reactor was also designed so it does not need salt for the reaction to take place. Usually people reduce carbon dioxide in a traditional liquid electrolyte like salty water, Wang said. You want the electricity to be conducted, but pure water electrolyte is too resistant. You need to add salts like sodium chloride or potassium bicarbonate so that ions can move freely in water. But when you generate formic acid that way, it mixes with the salts. For a majority of applications you have to remove the salts from the end product, which takes a lot of energy and cost. So we employed solid electrolytes that conduct protons and can be made of insoluble polymers or inorganic compounds, eliminating the need for salts. The reactor had an energy conservation efficiency of 42%, meaning almost half of the energy produced can be stored in the compound as a fuel. It ran for 100 hours with little to no sign of degradation, an important factor in scaling up technology like this. The team says that in the future, it will be able to produce reactors that produce even high concentrations of formic acid, and that the machine could be adapted to produce other fuels, including acetic acid, ethanol or propanol. Wenceslav Volev from the UK's University of Bath, who was not involved in the research, commented on the findings. It is really important to keep researching ways to reduce CO2, he told Newsweek. This work is quite original and seems well conducted. The authors have devised a new way to produce formic acid, found in most ants, which can serve as a biofuel. He said the reactor running for 100 hours with little degradation was encouraging, but added, given the global scale of the CO2 problem, it is fair to wonder whether the degradation would still be negligible after a week, a month, or a year. Future reactors, he added, should be further optimized. Presented by News of Voice. More news, www.newsofvoice.com. Our channel. Appreciate on like and comments. Thank you.